Okay, so I'm just going to fit in some examples for us to work on together. So you could pause here and see how you do, and then kind of check your answers. So here I see x times cosine. So I can see it's going to be integration by parts with the type that I want to let u equal the x term and dv equal the rest. So again, include the dx. So the derivative here is dx. The antiderivative here is going to be 1/4 sine of 4x. So again, the integration by parts formula is uv. So u x v 1/4 sine of 4x minus the antiderivative of v du. Okay, so this one here, I am going to take the time to clean it up. So many times just rewriting it that you can help see, is this something I know I should be able to take the antiderivative of? So you have to have wisdom of, can I do this or not? Can I take the antiderivative of this? I can. It's L'Hoyt theorem, so it's a 1/4 out in front. So carry this along. Carry this 1/4, and I'm going to be, let me just write that. Taking the antiderivative of sine of 4x is going to be a negative 1/4 cosine of 4x plus a c. Okay, that one's done. This one has a fraction. It's not looking too good, but I know I did give problems like this last semester. Your first really critical but not very profound step is to rewrite it as e to the negative 2x. Big important deal. Now I can see there are two functions multiplied times each other, an x times an e, which we had in the example, so let's go do it. So keep your u and your dv organized. That's why I'm showing this to you. So you want to let u equal the x and dv equal the e to the negative 2x dx. Again, include the dx with your dv. Here I'm going to take the derivative. So here I take the antiderivative. All right, so now let's put it together. So u v, remember if you have a subtraction, you need to put parentheses or deal with this negative so that it looks like multiply, not with just a dot, right? Minus the antiderivative of v, which is this, du, which is dx. Okay, so I'm just going to fix this up. Negative x over 2. So these coming outside gives me a positive 1/2. And is this something I know how to take the antiderivative of? It is. So the whole answer would give me a negative 1/4, because I get another negative 1/2 when I take that antiderivative and then put the plus c at the end. Okay. So here, both this one and this one, I'm looking at x squared. So I'm expecting to do parts twice. So make sure you stay nice and neat and organized. So let's do it. So it's x squared times a cosine, or x squared times an e, or an x squared times a sine. That's when you're going to have integration by parts twice. We're going to turn the page and it's going to be different. So make sure you're thinking about which type it is. All right, so du is 2x dx, antiderivative. So here the a is 1/3, so multiplying by 1 over a is going to be 3, and the angle stays the same. So I get u v minus the integral of v du. Okay, so for sure I want you to spend time cleaning this up. So I think it's, whoops, not one of it. I want to clean it up. So I pull the 3 and the 2 outside to be a 6. And I'm going to always put the x in the front so I can see the x times the trig function. So I cannot take the derivative or antiderivative of these two multiplied together. So I'm going to do parts again. So I'm going to let u equal the x, the dv equal the sine of x over 2 dx. So here du is dx, v will be negative 2. Oops, what did I do? I think I changed the angle, didn't I? So this should be a 3 inside here. I made a mistake. I'm glad I caught it now. Okay, by mistake I changed the angle. So x over 3 and 3, yes, okay. Okay, so now I've got this here. So now I'm going to get -3 cosine of x over 3. All right, so now let's put it together. So remember, this -6 has to stay on the outside. So -6, so I'll have uv, so I'll have -3x cosine of x over 3 minus the integral of v du. Okay, is this something I should be able to know how to take the antiderivative of? It is. I know how to take the antiderivative of that. So carry everything along. So no little dash lines, meaning like don't do this, like, oh yeah, this just carries along. No arrows, you got to do it. Just multiply it along. You could multiply this in or not. I'll just leave it the way it is. Okay, so this -3 comes outside to be a +3. Now I'm taking the antiderivative of cosine of x over 3, so I'll get another 3, and then I'll have sine of x over 3 plus c. Okay, last one. So here again, I'm expecting integration by parts twice. So I'm going to let u equal the x squared term, dv equaling e to the -x dx. All right, so du is 2x dx. And the antiderivative is 1 over a. Here the a is -1, so I get 1 over -1, which is negative e to the -x. All right, let's put it together. u v minus the integral of v du. Okay, so be careful with this. Let's pull that negative out in the front. So these two negatives make a positive, and I'm going to pull the number 2 on the outside. I find it's easier to pull all constants on the outside so they don't get lost in your parts. So here I'm going to let u equal, again I'm going to do parts because I have two functions multiplied times each other. So du is dx, and then the antiderivative will be 1 over a, 1 over -1, which is negative, e to the -x. All right, so carry this along. So I get uv, so -x e to the -x, minus the integral of v du. Okay, -x squared e to the -x. And I'm going to do it this time. I'm going to multiply this 2 in. So I get -2x e to the -x. Negative times this +2 gives me a +2. And then taking the integral of e to the -x gives me another e to the negative plus a c. Okay, so those are just some example problems that I worked for you. And then we're going to move on to type 2.